Okay, guys. So, okay. Again, I'm really sorry for the inconvenience of the incident. Excuse me, what's your name, please?
Natasha.
Natasha. I think you cleared it, right? Okay. All right. I'm sorry for that inconvenience. The incident. We have a couple of our classmates. They're being quarantined. Hopefully, they are coming back soon. So the class is being recorded for them. I hope it's working because this is the first time I use this. But yes, I hope it's working. So I'm gonna post it on YouTube just in case you want to rewatch it. This is for you guys also. Okay. Another thing is that I believe I already sent you guys the attendance sheet, right? Okay. Another thing is that you see the assignment. Our first assignment is due on according to the schedule, due on September 23rd. I think I'm gonna put it off until I'm gonna give you maybe a couple more weeks. So let's put the due date until September 16th. Okay, when you do the test, you submit the assignment. So assignment, I'm gonna put over here. Assignment number 1. Due September 16th. Okay. So we'll do September 16th. Alright. And I believe that I already said this. You can go ahead and start part 1 right now because we already learned how to solve linear equation last time. And you see that over here we have a fraction. So in order to do this, I have something similar to the 1A last time already. Go ahead and distribute it. For these 3 problems, B, C, and D, find LCD. Okay, so that's a hint. And I always want you to work together because right now with COVID, we cannot create a group. So it's the best way if you guys create a Zoom session where you guys can work on this problem together. I think it's gonna be faster than working by yourself. Okay, and the thing is that when you work it together, then you can help each other. Well, you can go ask the tutor too, but maybe this is more inconvenient. So I think working together on Zoom, set a Zoom time, a Zoom date for you to work together. I think that's the best way to do this. So go ahead and start 1A, B, C, and D. Okay. And by the time we finish the lecture today, I'm sure that you can do question number 2. Okay, so this is the word problem. Then I'm gonna let you guys know when you start part 3. Okay, everybody clear? Okay, so don't wait until the last day to start this. Go ahead and start now. So you need to contact somehow you contact each other, create a Zoom meeting where you can work among 3 or 4 or 5 students at the same time. This is going to be faster doing that. Okay? Alright. So today we're going to continue with section 2.2. So let me first of all, let me close all of this. Okay. In section 2.2, we will be talking about solving word problem. Last time you learned how to solve linear equation already, and as we know, linear equation can be used to model many word application problem. So today we're gonna do word problem. We learned how to set up linear equation from the word problem. Okay, so let's get started with the first type of word application. Section 2.2. Problem solving. Okay, the first type of word application I want you to do is called finding unknown number. Finding unknown number. And I have the problem like this. Let's write out the problem, okay? Find three numbers so that I forgot talking about MyMathLab. Everybody already registered for MyMathLab and finished the homework? Okay, good. Because I don't want you to get kicked out from the class for that reason. Okay, so you guys got to show some dedication toward the class. So find three numbers so that the second number is three more than twice the first number. Okay. Period. Given the sum of three number is 164. Alright. Solution. Okay, so how are we going to do this? So you see this is a word problem. And we need to translate this word into mathematical equation. Or I can say that we need to set up the equation from the given information here. Okay? And from that equation, we're going to solve for x. And that x represents something they ask you to find over here. So over here, they ask you to find what? They ask you to find three number. So that the second number is more than twice the first number. Okay? And the sum of three number is 164. So that is information they gave us. So how are we going to set up the equation here? Okay, so they asked us to find three number. Okay, so let's name variable for that number. Okay.
X, Y, Z.
X, Y, Z.
Y, Z. Yeah.
Oh, no. Because you never learned how to solve equation with three variables. So we need to bring it to one variable only, which is variable x, or variable n, or any variable. But the equation must contain one variable. Okay? If you have two variables, x and y, you cannot solve. So we need to bring it to one variable only. Alright, so how? Find three numbers so that the second number, so that information is very important, so I'm going to underline it. The second number is more than twice the first number. Oh, I think I missed another information, I'm sorry. So, and the third number, so, okay, here, the third number, okay, the third number is 4 times the first number. It's 4 times the first number. There you go. So this information is very important also. So I'm gonna underline this. Okay. Okay. So you see that in the first statement they compare the second number to the first number, right? And in this second statement, they also compare the third number to the first number. So I think that I'm gonna name x as the first number. I think that's the best way. Okay? So sometimes you can name x as the second number, you can name x as the third number, but one way will be easier than the other. Sometimes the way you name variable will be very hard for you to solve equation. So you have to name very smartly, very wisely. Okay? So I'm gonna name x. Okay, I'm gonna call x. Okay. Represent the first number. Okay, x represent the first number. Alright. Then what is the second number?
2x.
Okay, he said 2x, is that correct? Okay, the second number is what? Second number is 3 more than twice. What does it mean by that? 3 more than twice. Then what is the second number? 2x plus 3, very good. 2x plus 3. And the third number will be what? The number is what? The third number is just 4 times the first number. Just 4 times, just 4x. Alright, so after you name variable already, we know that these three numbers added up, because the sum, it means addition, give you 164. So I'm going to add those three numbers together. So I'm going to add the first one. So the first one is x, right? Then I add it to the second one is 2x plus 3. Right? Then I add to the third one is 4x. Then all of them give you 164. And now what do you see? I successfully created a linear equation with one variable x only. Okay? If we don't have variable y, only x. And because only x, we can solve for that. So how are we going to solve for that? Anyone?
Add like variable.
Okay, so I'm going to add all variable, right? Combine line term. So 2x plus 4x is 6x plus 6, plus x is 7x. Plus 3 equals 164. Then I subtract 4 side by 3.
X equals 23.
X equals 23. Alright. But that is just the first number. We want to find all three numbers. Okay? So the second number will be what? 2x plus 3. So it will be 2 times 23 plus 3. So 2 times 33 is 46. Plus 3 is 49. Okay, and the last number will be 4x, so just 4 times 23. Okay. 92. Okay, so that is our free number we want to find. Any questions so far? Alright, very good, very good. Okay. Another type of word application I want you to do is about distance, velocity, and time. Let me see I can find any over here. Alright. Okay. Example, so this is second time, so 2. Problem related to distance. Speed and time. Okay, so I have a problem like this. Two cars leave the same place at the same time one going east the other go west. The eastbound car, the eastbound car average 40 miles per hour. So that is they give you the speed of the eastbound car, and they also give you the westbound car speed is 50 miles per hour. So they give the speed of two cars. The question is, in how many hours will they be 300 miles apart? Okay. One going east, one going west, so they travel in opposite direction, right? And they live at the same place. Let's draw a quick picture. So I have this is a starting place right here, something like this. So, and the first car going east, right? So this is east one. So let's draw the arrow like this. I represent the first car. Okay, so this is your first car. Okay, and the other one going west. So when go this way, right? Okay. So this is the second car. Okay. So after a certain number of hours, so they gonna be 300 miles apart. So this is initial place. So after second hours, so they're gonna be around this much. 300 miles. Okay. And we need to know how many hours would it be. Okay. So in order to do this problem, you need to know the relation between distance, speed, and time. Anyone remember that? Anyone recall that formula between distance, rate, speed, and time? Anyone? The formulas, the relation between speed, time, and distance is distance represented by d is equal to v or s represents speed, time t represent time. Okay, so I want you to memorize this. D equal s time t. Distance equal speed time the time. Okay. Okay. Sometimes in some textbook, they don't use speed. They use velocity, but it's the same. Okay. So they probably put d equal v time t, v representing velocity. Or some textbook they use, probably my math lab, they probably use rate. So d equal to r time t, kind of the same thing. Rate, velocity, speed, kind of the same thing. So we're going to use this formula to set up the equation. Okay. So we know that the velocity, the speed for the first car over here is the westbound, right? So this is over here is 50 miles per hour right here. And over here is 40 miles per hour. Okay. They're asking for time. So it means that our equation must contain t representing time. Okay? So how are we going to do that? Anyone can help me find the distance, the number of miles the first car traveled?
Can be 50 times 50t plus 40t equals 300.
Yes, that is the equation. Because 50, why you do 50t? What does it mean by 50t?
Because it's the speed.
Okay, 50 times t give you what? Give you the distance, right? Because 50 is the speed of the second car. Okay, if you multiply by the number of hours traveling, it gives you the distance the second car traveled, right? So over here we can write. So I'm gonna call D1 represent distance. Distance of the first car traveling. Okay, and D2 represent distance of the second car traveling. Okay, so this from here to here is D1. So I'm sorry, this D2. And from here to here is D1. And we know that D1 plus D2 is 300, right? So D1 plus D2 equal 300. Okay. And D1 is equal to what? D1 equal to speed of the second car, which is 50 times t plus 40t equal 300. Alright, so right now we just go ahead and solve for t. 90t equal 300. And t equal to 30 divided by 9. Anyone do a quick calculation for me?
It's 0.3.
0.3? 0.33, right?
Yes.
Hours. So it's about 20 minutes. It's about that time. Okay. So after you find the number, actually we already find a solution for the question. But what if they ask you to find D1 and D2? Okay, you can find D1 and D2 easily. So D1 will be 133 times 50, right? Oh, that is D2. I'm sorry. Okay, and D1 is 133 times 40. And when you multiply these two numbers, and it gives you the distance the first car travel and the distance the second car travel. All right. Any question? Good. All right. That's good. All right. Yeah. I'm sure that I think the textbook we use probably in my MATLAB they use D equal R times T, but it's the same thing. Okay. Any concern on this before we jump into another type of word problem? Any question? Good? Everything's okay? Yes?
You wanted to tell you that it's T is 3.33, not 0.
Oh, 0. Why don't you just let me know? I heard it's called a pondering, so 3 pondering. So 3 hours. I trust you guys so much, that's the problem. Go ahead, Kate. Alright, very good. I think I'm gonna go ahead and erase it because we don't have enough space here. Okay. And a third type of word problem is related to we call it a mixture problem. So we mix one solution to another solution. How much 70% solution should be used? Okay. Solution. Answer. So when you deal with mixture problems, make sure that you're gonna draw you should draw the picture. Oh, sorry. You should draw the picture. So I have 40% acid solution, and you mix with 70% solution to make a 50% solution. Okay, so let's draw the pictures. So I have a container like this. Okay. And this is 40% solution. Okay, this A liter. Okay, A liter. And you mix with 70% solution. Okay, 70% solution. Okay, but we don't know how much, because they're asking us to find how much of 70% solution. So I'm going to call this X. Okay. Then we add this because we mix these two things, and it gives us what? It gives us a 50% solution. Okay. Okay. So we're gonna add all of this together, right? Because we mix them up, right? We're gonna mix them up. So because we pour this into this. Okay, we mix them up. So over here, it will be what? It will be 8 plus X. Okay. So based on the picture, actually you can set up equation easily. So what do we got? So how we gonna write the equation now? So we're gonna put A liters of 40% that you mix with. So it should be addition. Right. So we're gonna have what? 40% is 0.04, right? Oh, 0.4. 0.4 times A liter. Okay. Plus, mix them up. I mean, you add it. 0.7 times X equal what? Anyone? Equal what?
Equals 0.5
0.5
plus, no, 0.5 times A plus.
Times A plus X. Make sure that you have to put parentheses here. Without parentheses, will be wrong. Alright, so now we have the equation already, we can solve easily. So 0.4 times 8, anyone can give me the answer for that? So we can have 0.7x. Over here we can have 0.5 times 8 plus. Okay, so be 3.2, and over here will be what? This is 0.5. So 0.5 will be 4, right? And 0.5x. All right, now we just go ahead and solve for x. 0.7 subtract both sides by 0.5, so we can have 0.2x, right, equal 4 minus 3.2. So this could be, so I'm going to set 3.2 here, so it could be 8, right? And 0.8 divided by 0.2 give you 4. And that is the, but for what? Don't forget the unit. 4 liter. There you go. So you see the mixture problem is not really that bad, you know. Setup, I mean, as long as you draw the picture, actually, you don't have to, but if you draw the pictures, it's easier for you to understand. Okay? You mix them up, actually you pour this into the second cup into the first cup to create the bigger cup, something like that. Alright. Next, I want you to do this problem yourself, okay? So example 2, so this is example 1. Problem goes like this. The octane rating. Yes. Is a measure of its anti-knock quality period for a standard fuel. The octane rating is the percent of isooctane. So when you read the word problem, you just need to pick information, important information. Sometimes some information is it's not necessary, you know. But you have to see which one is the important information. How many liters of pure octane or pure isooctane should be mixed with 200 liter of 94% isooctane, referred to as 94 octane. Okay. To obtain a mixture that is 98% isooctane. Ooh, kind of confusing when you really read it. So let's work on this. Okay, I'll give you 10 minutes to work on that. Okay, go ahead. How many liters of pure isooctane should be mixed with 200% of 94% isooctane? Okay. to obtain a mixture that is 98% isocyanate. I think the most important part is right over here. You know, the first two statements is kind of, you don't need it. You don't need to know what antinop is. I don't even know what antinop is. Okay. So go ahead, try to draw the picture and set up the solution, the equation for that. Yes.
What does it say after isooctane? 94% isooctane.
Referred to as 94 octane. So this is just the name, you know. You don't. They put it over there so that they make you confused. So I don't think this part right here is really important. Because when they mix to another solution, they give us another name. That's what I mean. Something more problem for you to practice. So basically that's all for the concept today. Just word problem, but in order to be good at that, you must practice a lot. Okay. Let me see if I can find something for you to do. If you get the answer 400, then you got it right.
Wait a little bit more.
So we're just gonna go ahead and draw the picture. So I have 94%, 200 liters, and you have a pure isooctane. Okay, so it'll be 100%, right? X equal equal 98%, 200 plus X. Okay, so that's the picture. Pure mean